Good afternoon, everyone, and welcome to the 2022 AWS Summit. I am Jason Hogue. I'll be your room host for today. Some important housekeeping notes to share before the session begins. Emergency exits are located behind me. Bathrooms located right outside the front door to your left. Please remember to silence all of your devices, and if you have not done so, please download the AWS Events app from the App Store and share your feedback on this session through the app. We definitely value your feedback and will continue to listen to our customers. The AWS session that you see today is being recorded and it will be available a couple of weeks after the event. Today's session is titled Modernize Your Applications with Purpose-Built AWS Databases. And for today's session, we have two presenters, David Gardner and Kofi Ishan, both AWS solution architects. So please help me welcome to the stage Kofi Ishan.
And thank you guys all for being here today. Hello and welcome to Modernize Your Applications with Purpose-Built AWS Databases. So my name, as he said, is Kofi Ishan, and I'm a senior solutions database architect, and I've been with AWS for the last year. So today I'll be joined by principal database solutions architect David Gardner. So before we get started, let's take a look at the the agenda for today, right? So first we will take a look at the attributes that makes up for modern applications, and next we will talk about the architecture of a modern databases, and then I will touch on how we modernize application at Amazon.com. Now we will also pursue the ideal database, and then finally I will touch the modernization playbook for databases. And then for the second half of the session, I will turn things over to David, who will discuss more of the typical modernization journey. So okay, now let's get started. All right, so what is modernized application, right? Myself and then the AWS, database solutions architect, team, we have worked with, about thousands of customers to modernize the application. And when we look, at the modern database application our customers, deploy today, there are 7 key attributes that stands out. And, so we see these, apps designed for innovation and agility, or to put it in another way, Andy Jesse's first shareholders letter that he sent to the shareholders said something about iterative innovation is like compound interest. It's the gift that keeps on giving. So as you keep doing that, it kind of changes. With time it gets much better. So. And then we also have the performance and then the scalability. That is another key attribute that we will be looking at for today as well. So these are part of the 7 key attributes. And these apps, needs to be highly, available, and then most, with the more or less like the strict RTO and then the RPO requirements, and they may need to, be in a multi-region, for disaster recovery as well, right? So most companies also have limited resources to manage databases. So companies should not spend most of their time, managing limited resources, managing databases. It shouldn't be part of what they do. Now, finally, we do have the price versus performance, and it's kind of critical. So these applications must be what we call, cost effective. And transition, so in the context of those 7 attributes that we do have on the board here, what does it really mean to modernize your application from the architecture perspective? So if you look at the diagram there, so the modern data architect typically, evolves from a more or less like a monolithic and tightly coupled, architecture to, to decouple into different, decoupled, into microservices architecture. So the design time coupling, reduces the innovation and then the agility. So we need to kind of decouple our teams too, right? And we'll talk more about, decoupling of, people in the next slide. So the runtime, coupling, and then also the infrastructure coupling also reduces the availability as well. Now, on the left side, on my right, of course. On the right side, it's where we have those traditional 3-tier web application with layers. So you do have, they are tightly coupled, and then this, might, provide some level of, scalability and flexibility. But since you kind of, evolve and then scale, each layer individually, but in practice, it's kind of very hard to do, right? So it has limit. So on the other side, on this side of it, you can see that we do have, queues and event streaming to decouple, some of these services, and then in the infrastructure, component. And we have the classic database tier, is more or less complemented by the message and then the event streaming, and then the streaming solutions like the SQS, where ordering does not matter, or you have the Kinesis or Kafka, which ordering matters in them as well. Now, with the serverless and then the event-driven compute service, such as the AWS Lambda, that allows you to kind of easily build and decouple servers. You don't even have to worry about the provision of the infrastructure, and then I believe that you just put the code in there and it triggers and it goes off, right? So we also have the Amazon Elastic Contained Services, and then the Amazon Elastic Kubernetes, services, that these managed services kind of makes it much easier to run containerized, microservices as well. Now, let's talk about get to the pixel rule thing. So for Amazon, modernization started over 20 years, 20 years ago, and then the journey still continues. So back in 2001, we had, Amazon had one monolithic application, and then one monolithic relational databases. And, the application was directly accessing the database. Any database change that we had to go through a design review by the core DBA team, had to just make sure that they reviewed it. And you can imagine how painful those things were, right? So, and because of that, our time to go to market was kind of reduced. So our end goal was, the agility. So we could kind of, enable innovation, and it wasn't only that, that kind of the monolithic, database approach that was, handling everything that, was a problem. It was also the, every team that we had, everybody was so dependent on each other that we needed to make sure that we break that into different teams to handle that. So we had an idea, right? So what if we increase the amount of, the ownership of each team, right? But, decrease the, the scope of responsibility of the teams, and created, small teams, nimble teams with their own, database, and then the database staff as well. So we call that, concept a two-pixel team. And, the idea is to have two pixel, that can be fed for an entire, team at lunch. And I understand that, some of us have bigger appetite, and I know that it's not really ideal sometimes, but you get the idea of what we're trying to say, the concept here. So modular applications, right? We have the architecture with microservices. And it's not something really new, right? It wasn't even, at the time, but the organizational, changes, and then the governance structure, put in place would later become what is now called the DevOps. And this enabled us to kind of scale and then keep up with the tremendous growth of the company. So let's dive deeper into that two-team pizza thing. So these teams kind of align behind the API, right? So they align behind the API of the app, and they own the app from the beginning to the end. And then we call this service-oriented architecture, or SOA, but this is essentially the microservices, right? The teams are responsible for both developing and an operation of the service that they give. So we do have companies need to rethink about what is most important to them. So what they want to become, or their North Star, for 3 to 5 years. Now at Amazon, we kind of knew the time to market was our North Star. So we made a people and then technological decision to help support this thing, right? So we created the teams that are empowered to more or less to choose the right technology for their particular apps, and then also including the choice of the database, and then the interfaces for the data sharing that will abstract their internal database solution away from other teams that we're using. So that, and then away from the other teams were consuming these services and as such. So if you think about it, this approach, right? It creates a vicious cycle, and this cycle kind of, and as you can see, helps all the the complexity coming from the decentralization at bay, right? So organizational alignment of priorities, right, feeds into more or less like a governance framework, and this empowers our teams to own their own respective services and then establish a common a business language, right? And this gets up, the guardrails, to prevent, side channel activities as well. And then, this leads to teams, making the right, the right technological decision to support their, concerns, especially for database and data storage, and then the governance as well. Now, this leads to clearly defined internal interfaces and data sharing, contracts that prevent proliferation of practices such as, side channel, data access to one's team's, data stores, excessive ETLs, or, data movement processes and uncontrolled dependencies. So that all feeds back into the alignment of business priorities, helping, teams, teams determine where to, invest their resources or innovation as well. So, okay, so let's get back to the databases with them. So as we push for modernization, right, we are all in pursuit of the ideal database. So for as long as databases have existed, we have been searching all these, capabilities with no trade-offs. So this ideal database support all access patterns. It is strongly consistent, and then has infinite, scale as well. Oh, and then it's super fast, and it's easy to use, and it manages itself, right? So, and then of course it is cost effective, and then guess what? This does not even exist. So I'm not sure how many of you have the perfect database. If you have it, please raise your hand. If you have a perfect database, we can just have a discussion on it. Anyone? Okay. So this database doesn't have, there's always a trade-off, right? So even with when you have multimodal databases which claim to actually seek, this ideal outcome, come with, pretty serious trade-offs. So to this end, we kind of realize that we are more or less like, we can optimize for, a majority of these capabilities, but must, carefully control, some of the, the factors that, like access patterns, data storage, and then the data organization as well. So as you can see, the explosion of database solutions, this realization has actually led to the adoption of a wide variety of database solutions, as you can see today, right? So many of these deployed and self-managed, and others are more or less like, consumed as managed services as well. So having a variety of this, database kind of helps, teams have more nimble and pick the right tool for the right job, right? Instead of just saying everything goes back into relational databases, which we've done over the last, 2 decades. Everything just go back in there, whether it's NoSQL or not, we just put it in the same database. So this is typically done, based on the access patterns. And I believe David will talk more when he gets there. He gets here, and then other factors as well, and we'll discuss that later. So, as you can see, so we have these being broken down based on certain patterns, and most of these databases come across, right? So if you look closely to this model, and then the access patterns, we break it into a handful of purpose-built database categories, right? So the most common one, which I believe most of you guys use, is the relational databases. In the past, all the data models were made to fit into the relational database system. So this was more problematic both for scaling and then operations as well. So to enable the most demanding internet scale applications, new database engine have been created to support that, and you can see that, and many of our customers are currently kind of using that as well. So scaling, to scale is really actually driving the purpose-built architecture now, right, the pattern. So nowadays, database modernization is more or less a fact of life. So whether you realize it or not, right, you are somewhere on the modernization journey. And most customers that I've met, they already have created so many, micro services, using the databases for that. So let's talk a little bit more about this, journey. And we have helped, most of the customers have, we helped them on this journey over the years, and even my few year in Amazon, a few months I've been with Amazon, I've even encountered that, right? So we have developed, more of a prescriptive mechanism, that fit the steps, on this modernization journey, and then we call them the playbooks. So move to manage is about moving off the, the self, moving off, it's like the self-managed databases like the Oracle, the SQL Server, the MySQL, the Postgres, MongoDB, and so on, to Amazon, managed, services such as the RDS, and then the DocumentDB, and then with MongoDB's, back compatibilities. Now, we also are helping our customers, to break free from the legacy database, getting off the old guard, license, based databases, and moving into more of the open source databases engines, especially running on Amazon Aurora or the Amazon RDS. And then finally, right, I have our customers creating, new modern applications with purpose-built databases, and this breaks this monolithic, application into micro services, and then, and it kind of leverages the best database for the job instead of just saying everything goes into. I remember, in my past job, we'll put everything into, whether it's NoSQL, JSON files, whatever, we'll just dump it into the relational databases because we believe that it will solve all the problems. So as we head down this journey, right, and you can see this, the graph, it is important to focus on both the the tactical, migration as well as the more strategic, modernization journey. As you can see, you see the innovation keeps on going up, and then the time cost of ownership also decreases as, as we go through that, right? And many of our customers have actually, moved to the cloud by, lifting and shifting, on-prem database to EC2. So they are not even doing a straight modernization. They are just lifting and shifting to the EC2 servers. And these customers, they start to see both decrease in the cost of ownership and then also the increase in innovation as well as they do that. Now, as our, customers also move to a managed database, the costs are further reduced, and then the velocity of innovation, as you can see, continues to accelerate, right? So customers see the greatest savings, in cost, and then the highest velocity of, the high velocity of innovation in the cloud, native databases like when you use the Amazon Aurora or you use the DynamoDB, etc. There are so many of them that I just showed. So when they break up their monolithic database into modernized, purpose-built, I've been with a customer that they were actually, they were using, how do you call it? They were doing transportation services. They were storing everything into the relational databases, and everything wasn't working because there was a lot of latency. And what they ended up doing was put some of the data in RDS and then some of them in DynamoDB, and everything became faster. And then now they are very happy. So these are some of the benefits that you get. And in the end, they saw their innovation was going up, and then the total cost of ownership also kind of decreased. So. Come on up, David, and David is going to dive a little bit deeper into how this, this journey works with AWS. And thank you. All right, thank you. All right.
Thanks, Coffee. All right, so good. Come on. So I think Coffee provided you some experience that Amazon.com had in their modernization journey. Hopefully that gave you some good insight, both from a people, process, and technology, right? It's always fun, like the 2 pizza teams and things like that, to kind of talk about at Amazon, so you can Google those stories. But let's kind of focus now on kind of more of the journey itself, and then also in the different technology services that AWS has. And so most journeys start at the relational database, right? So everybody here, took relational theory in college, or some of us, right? So English majors probably didn't do that, but I know from computer science perspective and others, and development, right? So relational databases have been around for decades, right? So in fact, they were built at a time where storage was probably the most scarce resource or most expensive resource that we had to deal with. That's changed, right? I mean, like terabytes or cents per gig, stuff like that. And so that's the economies have changed, right? And so has databases in general. But the most common known database really is around the relational database. And so a lot of existing business processes and applications were built using those relational databases as well. In the startup space, right? They want to go fast, right? They need to build it, and so since that relational database is the most commonly used database, and there's lots of knowledge around it, some of them will start there. There's also ORM models and low-code approaches, right? That use back-end databases or relational databases as the back-end, and so most folks start here on their modernization journey with that relational database and moving more into. As Kofi talked about the journey, right? So let's kind of start that journey here. So when we work with customers, typically the step one is a move to manage, right? So how can I, alleviate the operational burden of managing a database, right? So the agility, ease of management, and the cost effectiveness of moving from a self-managed database to a managed database service, frees up your DBA times, right? So a lot of discussions that I have with DBAs are like, oh man, what's my role in this, right? So I mean, what am I going to do? So there's definitely roles for DBAs, even with managed database services, right? So we want to get the DBAs out of the writing the backup script, writing the configuration scripts to spin up databases, installing the database software, right? That's not a core business differentiating, feature of your company, right? Let's go focus on things that actually make your company, most special to your customers, right? right, and add innovation and business benefit, and take those, we use the term undifferentiated heavy lifting of configuration scripts, things like that, and move those to a managed service provider in the database space like AWS, right? So now instead of managing maybe 5 to 10, or so databases, right? As a DBA, you start to be able to manage hundreds, maybe even thousands of databases because now a lot of it is automated, right? And so step one is move to that manage. So in the space of managed database offerings, we have our relational database service and/or RDS. How many folks here use RDS today? Okay, I got a few. Yeah, so it's definitely focused on, we have 5 engines that we support today, and that's MariaDB, MySQL, Postgres, SQL Server, and Oracle. And so we see a lot of customers that, moving their, existing databases and moving over to RDS in order to, get that ease of administration, performance, scalability, as well as the availability and durability, right? So for example, in AWS, we have multiple availability zones, right, which are multiple data centers. And if I want to be able to leverage that within my database space, this is now just a checkbox, right? So scalability, the availability of the database is really just an API call or an adjustment inside, my configuration. Versus if you're thinking about doing that self-managed, right? If it's Oracle, you got to do your Active Data Guard, set that up, or for SQL Server, it's the always-on availability groups, or logical replication, right? So within RDS, it's a checkbox, and we'll take care of all that for you, right? So it's much faster and easier for you to be able to do that inside that managed database service. And we also kind of cover the patching, backups, monitoring's automatically built in. We use the CloudWatch service, CloudTrail, other things are kind of all built into that service, right? So we have a concept, or an example is like whether you eat your own dog food or drink your own champagne, whichever analogy you like to prefer. But we do leverage that inside RDS, right? So we use a lot of other services inside of RDS to be able to deliver that managed service for you, right? So again, step one, leveraging RDS to kind of offload that DBA management services. But as I mentioned, there's still the role for the DBA. It's just a little bit different than what you've been doing on-prem. So within the managed database space, in talking with customers, one of the things they came back and said to us like, hey, we love this open source database thing, right? But we really would like it to have greater availability and greater performance. And so being customer obsessed at Amazon, our engineers went off and said, hey, let's kind of break this database hierarchy together, and let's create something that's cloud-based, serverless and scalable on the storage side. And that's where we came up with Aurora, right? So it's a drop-in compatible with MySQL and Postgres. And what we kind of did, so if you look at the top of the chart here, SQL transactions caching within a database engine, right? Those kind of all stay the same, but under the covers, we changed the storage layer, right? So now you have a distributed, cloud-native, log-based storage layer in that from the application, it still looks like MySQL or Postgres, but we're actually leveraging that storage under the covers, making 6 copies of your data across 3 availability zones such that it is highly available, and the storage is also self-healing, and it also scales out, right? So I can basically get the I/O that I need versus being very tightly integrated with like the Elastic Block Storage or storage that's there attached to the instance itself. So this scaling storage is also distributed, and again, it's log-based sequencing within the storage layer, and that gives Aurora the capabilities to have greater availability and performance, but still open source, right? So there's no lock-in here. If I want to, PG dump into Aurora or PG dump back out and go back on-prem, you have that flexibility within Aurora. So it is cost-effective. It also provides the availability of those commercial databases. And as with everything with AWS, it's a simple pay-as-you-go service type of model, right? A couple additional features within Aurora that we've added recently. The second bullet there talks about compatibility with T-SQL. So Postgres is a very extensible database, right? So for example, like geospatial, you have your PostGIS and other extensibility functions within Postgres to be able to do that. So one extension that we've added to Postgres is called Babelfish, and that allows a Postgres database to actually speak SQL Server, right? So you can take a SQL Server application, your T-SQL code, you can actually run it on top of the backend database actually is an Aurora Postgres. So your application layer thinks it's talking to a SQL Server, but in actuality it's talking to a Postgres database, right? So that was just generally available at the first quarter of this year. We continue to work with customers, and there's been a lot of interest in using Babelfish for their kind of legacy SQL Server database applications that they've got. The other feature is global database, so a lot of customers need multi-region capabilities and DR purposes. Aurora has that built in to the infrastructure, so you basically just say, hey, global database, what region do I want to add? Ding, and then we basically set up all the replication and storage layers between whether it's US East or US West. We take care of all that for you. And then the last is the feature on the slide here is serverless database. So serverless databases with Aurora, we introduced probably about 1.5 years, 2 years ago. We also just generally available released the version 2 of serverless, which really broadens the use cases that serverless enables you to leverage serverless for. And so a lot of customers that I work with are now trying to adopt the serverless features within Aurora inside their workloads now that pretty much all the normal Aurora features are available on the serverless model, right? So now you can scale that compute just like you can scale the storage. Which leads to the next slide where we talk about the evolution of the database, right? So if we start over on the left-hand side here, it's a very tightly coupled database, right? So I know Coffee talked a lot about tightly coupling things in the monolithic application. Same thing here, the database and the storage are very like a one contiguous unit, right? And so with our first iteration of evolving that with Aurora, we took the storage layer and the compute, separated those. We made the storage layer, a fleet of storage services that can automatically grow and shrink as your workload needs on the storage layer. And then on the serverless side, with Serverless v2, we really take the compute side and also make it to where it'll grow and shrink within your workloads, and that the adjustment to the compute happens in milliseconds, right? So it can scale very quickly without having to shift an instance under the covers and basically add more CPU and memory to your workload as it needs to, and then as that demand goes back down, shrinks back down, right? So again, only paying for the compute and resources that you need. Gives you a lot of flexibility inside of your database engine to be able to scale it both vertically as well as horizontally with the traditional like scaling your readers on the Aurora side, right? So definitely been excited about that for customers to be able to leverage it and look forward to, like I said, I've got a couple of customers that are in process of moving over from a provisioned Aurora cluster to the serverless. So a customer example of using RDS and Aurora is Reddit. So it's a top 20 website that's out on the internet. One of the things that they experienced was humongous growth inside of their database and infrastructure services, so they were constantly trying to keep up with that. So their challenge was they were running on a self-managed Postgres database. And so one of the things they did was they moved over to Aurora. And as you can see here from the quote from Jason Harvey, it's be able to focus more on the long-term strategic things versus the daily care and feeding of their databases as they had more success and customers using their site and platform, right? So the solution was to move from that self-managed database to the managed database services and Aurora to be able to scale that out and move a lot of that database management to the service from AWS. So step 2 in the journey, so we talked about kind of moving from self-managed to managed. Now we're going to talk about another kind of easy way or low-hanging fruit is to adopt caching, right? So if you have a very read-heavy database, or if maybe I'm keeping a game leaderboard or some type of session state information, I can offload that into a caching layer and use a persistent or a memory database and move that out of my relational database, right? And the coding there, it's a fairly easy lift, right? So if I just do a quick, hey, is this value, somebody's doing a search for this value or this query, is this in the cache? Yes, go get it. If not, go back to the database, right? So it's not a heavy lift to add that little snippet of code inside your application to be able to leverage that. And then you move that workload off of your relational database into something that's very fast for your read-heavy workloads, right? So frequent counters, fast-changing rankings, sub-millisecond data access, right? So this memory caching layer definitely adds value into your application as well as scalability. So we're going to talk about Elastic Cache, which is similar to our relational database service for relational databases. Elastic Cache is that for our caching and in-memory databases. And so Elastic Cache has 3 different flavors. The first is Elastic Cache for Memcached. And so that's a very simple, quick, key value lookup type of caching in-memory database. And so you can see the persistence here is that there's really no persistence, right? So it's really ephemeral, right? So if I have a use case or a workload like website looking up values, it can be very beneficial and easy to use Memcached. And so we'll see in terms of durability, there's also Elastic Cache for Redis, right? So Redis certainly has a much broader command set as well as use cases that it handles. It also has some persistence built into the Elastic Cache in terms of replication and in failover, right? So we see a lot of customers using Redis as their in-memory solution and using Elastic Cache to offload that management of a Redis cluster to a managed service like AWS. And on the far right-hand side here is MemoryDB, right? That's probably the most recent add to our caching solutions. We just GA'd that or announced that at reInvent this past year. And so what we basically have done, it's still your same Redis client and server commands and backend, but we actually have made it now a durably written caching database, right? So. And we'll get into a little bit more details on how exactly we do that with MemoryDB in a slide or two. But then this is your options in terms of being able to add a caching layer into your applications to be able to modernize them. So a customer example of this is PayPay. They're a top financial services online payment solution in Japan. And so they needed to roll out a new QR code, those little fancy scan QR codes that everybody loves now. They were going to add a new service around QR code payment services. And they were able to do this in about 3 months to be able to add a new service and capabilities inside their applications. In order to do that, they needed so this is within all their API calls, they needed the authorization service, right? So think about, customers doing payment transactions. Nobody here likes to wait, right, when you're trying to, do a payment, right? So these had to be sub-millisecond type of response times inside that API application stack. And so they picked Elastic Cache with Redis to be able to, every API call goes to that service and checks the authorization token for that API before they actually go through the payment, right? So this enabled them to be able to add this to their stack and to be able to roll this service out to their customers in very quick time. And so I won't read you the whole quote there, but really the key thing from PayPay was that Elastic Cache enabled them to be able to not only be able to perform it and scale like they needed to, but to do so without having to do a lot of heavy lifting themselves to be able to do that. As Coffee talked about, being able to innovate and agility, right? So they were able to do this new service in a relatively short amount of time. So it's a great example of being able to leverage caching inside your application to be able to enable new capabilities and features for your customers. So to dig a little bit deeper into MemoryDB, which is our most recent add to the caching layer. And so it's still the same Redis compatible engine under the covers. It provides ultra fast performance, right? So it's the fastest database solution of any of our managed database services that we have at AWS. And so Redis is one of the most favored. If you look at like the DB engine ranking, Redis is in the top, favored database engines that are out there. And so this enables you, and the way that we changed this within just kind of normal Redis is that if you look here, there's a synchronous and an asynchronous functions that are happening under the covers. So for you, from an application perspective, it's still the same Redis client set, and so I'm going to set A to 100. And so the primary cluster is going to accept that, and at the same time, the primary endpoint is going to write that to a multiple availability zone transaction log under the covers, and once that is acknowledged, then we'll go back to the client and say, yep, this is durably written, we're good. Then under the covers, we'll take care of asynchronously replicating that to all your replicas across all your availability zones within your Redis cluster, right? So the key takeaway here is that it's still the same Redis compatible code, but now you have a persisted, durably written in-memory, cache capability, right? So once it's written to that transaction log, that covers multiple availability zones, it's also durably written there. And now, so if you are using today maybe Elastic Cache or Redis cluster with your database, you potentially could replace both of those with MemoryDB and be able to get persistence as well as the durability and the performance in a single platform versus having the two, right? So it's definitely something that customers are looking at and adopting with MemoryDB. So that covers step 2, which is kind of like all the easy things, right? We moved to manage, we added a caching layer, offloaded some of those read-heavy things or game, leaderboards or maybe some reporting or counts. So now we get down into breaking the monolithic, right? So this is where we want to get to whether you use the strangulation pattern or if you use the siphon off of different services inside your monolith and move those to their own purpose-built microservice using a different database storage under the covers. And so this is where we get into our non-relational or NoSQL solutions inside AWS managed databases. So we have DynamoDB for your key value lookups, DocumentDB for documents or nested JSON, and then we get into key spaces for wide column or if you're using Cassandra capabilities. So the key benefits here are going to be agility, scalability, and performance. So an example of this on the Amazon.com side is for Prime Day last year, we're up to 80 million transactions per second, supporting the cart functions and everyone ordering items off of Amazon, right? So being able to do that in a relational database is very difficult, right? So that's why we use DynamoDB for that key value lookup and capabilities to be able to scale and meet the demands of our customers in that space. So as mentioned, DynamoDB, just some more details on it. So it's basically performance at any scale, right? So it gives single-digit millisecond type of latency, whether you have 10 requests or that 80 million transactions per second that we run like on Prime Day, right? So we also have lots of social media providers for like Super Bowl events and things like that. They get into the tens of millions of type of writes with DynamoDB on the back end to be able to do that. One of my favorite stories is my first customer when I started working with AWS 6 years ago. We deployed a very simple microservice with DynamoDB on the back end. And about a year ago, I talked with this customer, and we were in the throes of Postgres 9.6 upgrade, right? Because it went end of life, right? So there's all this painful, like all my fleet of Postgres databases, I've got to make this upgrade. And the customer said to me, he's like, that thing we did on DynamoDB 5 years? He's like, we have never had to do anything like this for that. It just runs, right? It just works. It's maintenance free, it scales as we need to, and it's super low cost, right? So definitely if you're looking at building new microservices, DynamoDB is certainly something to take a look at for that key value lookup type of workload, right, as your persistence layer. It does have 5 nines of availability built into DynamoDB when you leverage the global tables feature, right? So if you need, multi-region, multi-write capabilities, it already has that, and including the conflict resolution is already built into the service. DynamoDB also has enterprise-ready services like ACID transactions, encryption at rest, continuous backups. It also integrates with lots of other AWS services, right? So from a workload perspective and using the NoSQL database, DynamoDB is really ideal for serverless or event-driven architectures. It also has the global resiliency service and then also high throughput workloads, right? The funny story is when I work with DBA teams, a lot of them are like, oh, we don't need to know DynamoDB, we're good for that. A couple of weeks later, they'll be like, oh, our application teams, they're using DynamoDB all over the place. And so can you come and give us an immersion day on DynamoDB so we can learn about this? Because we actually are going to end up supporting this we didn't think we were, right? So more than likely inside your company, your application teams are probably using DynamoDB under the covers, whether you may be aware of that yet or not. So a customer example, right? So I think we all had those experiences with COVID, right? Where birthday parties, graduations, we couldn't do those in person anymore. So an example customer is Zoom, right? So I think everybody here did Zoom calls, right? With birthdays or, whether it's, graduations, things like that. We had to do those over Zoom. So Zoom on the back end runs AWS DynamoDB. And so having that scalability within DynamoDB allowed them not to go from a 5 to 10x increase in, the amount of throughput and performance and scaling, but they can handle that COVID pandemic level of scaling that they experienced, right? And so the challenge for Zoom really was to be able to scale with that pandemic type of scaling that they needed to be able to support and keep everybody, mostly sane while we had to stay home and couldn't really travel anywhere and see folks, right? So the solution here really was being able to leverage the DynamoDB, both the global table feature as well as the scaling capabilities of DynamoDB to be able to scale up from where they were pre-COVID into that COVID type of scaling that they needed to be able to do that. So DocumentDB. So for Whether you have maybe a mobile application or anything that has a JSON content management, or where you have nested JSON data, DocumentDB provides you a Mongo compatible type of API where you can be able to use those nested JSON capabilities at a managed service to be able to leverage that. And so it's fast and scaling. We talked about the Aurora storage layer, very similar storage layer here for DocumentDB, right? It automatically scales the I/O and the storage as you need to, all the way up to 64 terabytes, right? You can scale out the read replicas up to 15. It also supports multi-region database, right? So I can do a global data store within DocumentDB to have high availability. And it does have enterprise-ready type of features with that built-in high availability, durability by default, as well as encryption and monitoring built into the service, right? And it is MongoDB compatible APIs, right? 4.0 and prior. So we cover most of the key Mongo APIs that are out there and used by customers, right? We don't cover all of them, but we cover like the 80% of the ones that are actually get used. So, and so from a DocumentDB, ideal use case, again, that's where I have content management. So for example, if I have or mobile users or anything where I have like a JSON and I want to be able to query inside that JSON string, right? And to be able to use that. So it's also used for real-time big data and or user products and profiles, right? So if I need to be able to provide that to customers where maybe the product description is a long JSON file and I want to be able to look for inside the nested JSON, DocumentDB gives you those capabilities from a NoSQL solution perspective. Keyspace, and so a lot of customers came to us that were running Apache Cassandra, right? When you get to Cassandra clusters at large scale, management becomes a big overhead burden. And so in order to kind of help address that with customers, we came out with Keyspaces, right? So it's fully managed, Cassandra-compatible database service without the burden of overhead of managing a Cassandra cluster. And so it is, compatible with Apache Cassandra, performs on a scale. It's also a serverless service, and it also provides lots of enterprise-ready features, right? So the use case for ideal workloads for Keyspaces, maybe where if you're using Cassandra today, or your development group has Cassandra experience, you can certainly leverage Keyspaces to kind of offload that management there. So schema validation, multi-independent stores, as well as be able to store in rows of 1 million bytes. Step 4, which is the last step, and you could intermingle step 3 and 4. I've got customers that are like, hey, we really want to be able to use Graph for personalization and recommendation engines, right? So you can certainly kind of intermingle 3 and 4 together. So at 3, we cover the specialized data sets, or I call them boutique database services, right? And that's where you have like social graphs, recommendation engines, measurements, systems of records, or digital records. And we have database services, which are Neptune, TimeStream, and QLDB that we'll cover. And again, the key benefits here are the agility, scalability, and performance that you can get within those special design use cases. So Neptune we'll cover first. So that is our fully reliable graph database service for the cloud. We support the open source property graph of Gremlin or Tinkerpop server, as well as the W3 RDF graph models within the Neptune engine, right? So the key thing here is we provide, a similar scaling engine. Again, if you're familiar with the Aurora, where we make 6 copies across 3 AZs, we give you that kind of reliability and performance within the Neptune space to be able to run your graph databases and workloads inside of the Neptune platform. And so again, it also supports Gremlin and Sparkle. We also added OpenCipher, which is another commonly used graph capabilities. And really, so for graphs, that's really where the relationship of the data matters as much as the data itself, right? To be able to measure the strength, the weight, and the quality of those relationships, right? So if you think about a mobile application and the churn model, right? So if Sue is going to leave, who all does Sue have the most, who might be the likely to depart with Sue if she churns, right? So doing that type of analytics certainly fits well into a graph database. So social networking, recommendations, fraud detection, as well as life sciences are some of the common use cases we see within Graph. And so an example, right, so who here does fantasy football or fantasy sports, right? I did my first year this past year with my son. doing fantasy football, and so Dream 11 is a fantasy sports social network service, and so when they built their social networking service or added on that feature into their capabilities, they used Amazon Neptune under the covers to be able to do that type of analysis of who likes to participate in games with who, and so they used Neptune as part of the reads and writes for the social network analysis, and they also used Elastic Cache for that, sub-millisecond type of response time inside their architecture, right? So you can certainly leverage multiple purpose-built databases together. Next is TimeStream, and so the example customer that I have working with TimeStream, they have devices out in the field. These devices send data every 15 minutes, and so they're collecting that, and they want to be able to report, is there some anomalies going on in the field with these particular devices, and I want to optimize the amount of energy output that these devices do. And so they're using TimeStream on the back end, which is a serverless service, and we actually break the ingest, the storage, and the query into separate components that can each scale on their own. And so basically send that data in. They're able to use SQL Engine to be able to query that very quickly. It is so to collect, store, process that time series data at any scale. And again, it is a serverless type of service, right? And we scale up. On the storage side, it initially comes into an in-memory store, and then as the data ages out, we move it to regular hard drives, right, under the covers for you, and the query engine just automatically can search across both those for you, and you don't have to worry about that, right? So good use cases for TimeStream is where you have real-time performance tracking, forecasting, trend analysis, or events, or anytime you're using time type of data, right? So whether it's devices streaming data in, and you want to do some type of analytics, those are good use cases for TimeStream. And the last database service that we'll talk about is QLDB. This is a fully managed ledger database, right? So if you think about journaling, right? So inside QLDB, the journal really is the database, right? So we actually update the journal before we actually update the rows, right? So it is a auditable, cryptoviably verified, change of your database, right? It's also a serverless service. And where QLDB really gets into its use cases is I need to have a database where I can track the history of the data over time and be able to verify it, right? So maybe it's system of record, blockchain, maybe it's healthcare records or patient records. I want to be able to verify the changes of a patient over time. Those might be good use cases for QLDB, and also the state of the change, right? It's also immutable, depend only. It also, on the SQL side, it does use Particle, and so basically gives you a query-like interface into the QLDB database for those cases where you need a ledger type of database to track all those changes, right? So the next step, after we've kind of modernized our application, and you kind of see the outer ring here is all those operational transactional systems, we want to bring that together for analytics, right? And so this is where you merge all those transactions into a data lake. And so we commonly use S3, which is our simple storage service, and pushing all that data in, and that enables us to do analytics and machine learning on our data, no matter what purpose-built database we might be using. And some of these databases, like for example, Neptune, Aurora, we also have built-in machine learning algorithms that you can call from the database itself as well. But this really story here is to kind of unify my data, collect it all together so that I can do analytics across all my multi-channels of marketing or contacts with my customer. All right, so to sum it all up, we talked about the 4 steps in modernizing your applications. We started out with moving to manage, so whether that's RDS or Aurora, enabling caching and offloading that read-heavy workload to either Elastic Cache or Redis or MemoryDB. Then we used non-relational solutions in our NoSQL space, such as DynamoDB or DocumentDB or Keyspaces. And then we added in our specialized databases of Neptune, TimeStream, and QLDB for those particular use cases as well. So continuous learning, right? So we want to learn on demand. We have lots of digital free services. So I'll leave this slide up here for a little bit. You also will get the slides. But this kind of gives you the QR codes for training, as well as we recommend AWS getting certifications as possible and being part of the certified community. So I want to say thank you on behalf of Coffee and myself, and we'll be in the hallway afterwards. I think there's a session here in the room after we start, but we'll be glad to take all your questions out in the hallway afterwards. Thanks again for being here, and hopefully you got some ideas and thoughts on your modernization journey to start. Thank you.